Whew. Part five. Part five. All right, ladies and gentlemen, welcome to the last and final part of this packet. WED, weathering, erosion, and deposition. Hope you understand it so far. All right, so in this last part, we're gonna be discussing about deposition, which is the last leg of the weathering, erosion, and deposition process. So exactly what is deposition? Now, deposition takes place when sediments are dropped, when sediments when are moved and put in a new environment. Okay, so this usually would occur where the river has lost all its energy, or the agent of erosion pushing these sediments or moving these sediments no longer have the energy or the necessary requirements to keep moving these sediments, and as a result they are dropped. So typically this would happen at the bottom of the ocean, or at a lake, or at the base of a hill or a mountain, and we kind of touched a little bit of that when it comes to agent gravity and agent glacier, where they drop their sediments from a higher elevation to the base of the mountain, and stuff like that. Okay, all right. So because stream loses most of their strength at the point where they enter into the ocean, all right, that's the point where they have the least energy. They're gonna drop lots of those sediments right at the peak between when the river is leaving the continent and joining in the ocean. All right, so we have a continental environment and then we have the oceanic environment, just the way we have continental plates and oceanic plates. All right, so when these two environment meets right in around that area, that's when the energy of the river is at the lowest point, and that's where most of the sediments are going to take place. So the point I'm trying to make here is deposition is very dominant in a coastal region, a region that is very close to the ocean, or the land that is very close to the ocean. So as a result, different landforms are formed around the coastal region. Typically, you have your beach. Everybody goes to the beach. I know my pronunciation is a little bit off, but that's just the way I pronounce it. We all go to the beach. So the beach is where a lot of sands has been deposited, just facing right the ocean. So we are all familiar with that. Another good land that is formed around there is what you call the barrier island, or barrier spit, or bay barrier. Typically it's just a deposition of sand that is created, kind of trying to separate the oceanic environment from the continental environment, and then it's just like a bar. So this long bar will be called barrier arc. A little bit of more about that as we proceed. Then you have the lagoon. The lagoon is just a body of water that has been cut off from the ocean itself. So as a result, they don't receive fresh water, or when the waves come in, when the tidal waves come in, it does not really renew the water inside the lagoon. So the lagoon is like a trap set of water in an area, usually in the coastal area. That's what a lagoon is. I think those are the main important ones that you should take from this lecture, so I don't want to flood your mind with a lot of things. Another important one that is also created is the delta. All right, a delta is when the river, just before it joins the ocean, splits into several distributaries. Right, we talked about tributaries later on, earlier on. Tributaries is when a smaller river joins a bigger body, or joins a bigger river. Distributaries, however, to distribute, we are no longer paying tribute, but rather we are distributing. So the river split itself into several distributaries. So the river distributes itself into the ocean. So each of those tiny rivers are called distributaries, and all of those fan shape in that area is called a delta. So it's usually like the shape of a fan, where the river splits into several tiny rivers, creating a delta. We talked about barrier arc in the last slide, and then we talked about lagoon also in the last slide as well, a body of water that is just barricaded from the main ocean, making the water to be a little bit stuck, and then the water would definitely be more blackish, which means it has a lot of plaques in it. Typically it will be darker in color and maybe smell a little because it does not get refreshed by the waves coming back and forth. What else is important here that we should discuss? I think pretty much that would be it. Okay, so this is what a delta would look like. So the main river comes in, and just before the main river joins the main ocean, it splits itself into several distributaries, several tiny rivers before joining the ocean. So all of this formation in this area is called the delta. In Nigeria, where I'm from the Niger Delta area of Nigeria. In fact, the name of the state I'm from is called Delta State, and it's right around the Delta area. So the river here, River Niger, in which from which Nigeria is named Nigeria. So that river Niger right there, just before that river joins the Atlantic Ocean, it splits itself into several distributaries. So all of that is called the delta. Hence my state was named Delta State. I live very close to Warri. Talking about contributaries, you can see that this river here, or this other rivers, joins this bigger river, and then that bigger river joins the main river in Nigeria, the Niger. So all of these rivers are tributaries because they are paying tribute. They are joining a bigger river, and then the Niger itself splits into distributaries, distributing itself into the Atlantic Ocean, splitting into several smaller rivers before joining the Atlantic. So typically this is what a delta formation would look like. So over thousands of years, as more water comes in from the inland into the ocean, the delta begins to develop right around there, and eventually it comes out strong after thousands and thousands of years and thousands of deposition. Remember, the sediments being deposited here are mainly the smallest size of sediments, sand, silt, and clay, because the river is now very weak as it gets into the ocean. Next, we talked about the barrier island. So the barrier island is like a barricade, from the word barrier, to create a barrier, to create a barricade. So a barrier island is a piece of island surrounded by water. That's what an island is. An island typically is a piece of land surrounded by water, but however, it is elongated and stretched across the coast, trying to create a barricade between the ocean itself and the continent itself. So this is all of the continent, the coastal area, and this is the ocean, and then you have that barrier island coming in to interject. Typically, Long Island in New York is a barrier island. All right, barrier island is more pronounced here. You can see that barrier right there trying to separate the ocean from the continent, and then you can see the same barrier island stretching. So barrier islands are usually not very thick, they are long and stretched, creating a barrier. Next, you have a sandbar. A sandbar is a piece of sand that is deposited, just the way the name implies, a bar of sand. So it's just purely sand that is deposited in a coastal area, nothing else but just sand, usually elongated as well, but it's not a barrier island, but it's just typically made up of sand, just like a beach, but the beach is not in the coastal area. The beach is a little bit towards the ocean. All right, this is what it will look like. A sandbar would look like as well. All right, and then beach, we all know what that is. It's all of these sandy areas that are produced here. So you take note that all of these landforms that we've discussed, what is actually producing them is the waves action, the action of the waves coming from the ocean. So this is the action of waves taking place here, depositing and creating these landforms that we are talking about. So very important that you take note of that. All right, Next, we're going to discuss wind deposition. So when wind deposits sediment, you have the sand dunes. Typically, you see a lot of this in the desert. And if you study the sand dunes critically enough, you can tell the direction that the wind is coming from. The direction the wind is coming from always have a gentle slope. All right, the slope will be gentle. And then another kind of deposit that wind also creates is the loess. Usually they are very fertile sediment, silt and dust and a bit of clay that is deposited and accumulated. Very good for farming. Yeah, so very fertile. So these are the two kinds of deposition that wind will create: sand dunes and loess. Next, deposition by gravity. Needless to say, though, for the other kinds of deposition that we've looked at so far, you can see that it is salted. The sediments are usually salted, which means they all have the same sizes. The sandbars, the barrier island, they're all made up of sediments of the same sizes. Same thing with agent wind. When agent wind makes deposit, it tries to sort them out as well. But agent gravity, on the other hand, when it deposits a sediment, there is no sorting, because gravity just pulls everything. It has a lot of energy. It is bulky. That is why it's called mass movement. It moves mass of sediments without sorting them. So both boulders and cobbles and pebbles and silt and clay are just dragged down from a higher elevation to a lower elevation. So the sediments are not sorted. And because the sediments have not traveled a long distance or thousands and thousands of kilometers, the sediments are angular. The sediments are not rounded because they traveled a very short distance. So the sediments will be unsalted and angular. All right, so typical example include landslide, rockfall, mud flow, soil creep, and slumps. Soil creep is very critical. The next thing is very tricky. The key thing to know about it is that as the slope goes downward, because soil creep, the soil is very small, it is not very noticeable, but you will notice it with the sagging electrical installations, or the roots of the trees, the trunk of the trees will be slightly bent. So always watch out for that in any regent question. It's an evidence that soil creep is taking place, which means the soil is gradually creeping down the slope. All right, so that is deposition by gravity. Next, we're going to look at deposition by glacier. Also very technical as well, but as we said during ancient glacier is called the Nature's bulldozer. So when glaciers, massive, huge of ice, lot of weight, as they slide down the slope, they bulldoze different sediments of different sizes and then brings them here. So initially this glacier was all the way up here, so that's what you call glacial retreat. So when an ice age is ending, the glacier begins to melt and melt, so it's retreating or receding backwards. So when the glacier starts receding backwards, the deposit, the sediments that it has pushed over the thousands of years downward, those sediments, they are called moraine. Moraine. M-O-R-A-I-N. Moraine. And typically moraine will have different sizes of sediments, and they are usually angular as well, because the glacier froze them and brought them there, or pushed all of them there, not over a great distance. So there is no room for abrasion. So the sediments we're not hitting one another. So the sediments are not abraded, they are not smooth, they are not rounded. So as a result, the sediments will be angular as well and unsalted. So all the sediments in a moraine, they are angular and unsalted. All right. As a glacier resides, also it creates what you call the kettle lakes. Kettle lakes right around here and right around there and right around here. In upstate New York, we have some kettle lakes there. If you look at your ESRT page 3 and 2, I believe. Okay, what else do we need to know from deposition by glacier? We talked about moraine, we talked about kettle lakes. So as the glacier gradually resides, it begins to melt, and then a little river start coming from the glacier as a result of the melting. Now the sediments coming from those river coming as the glacier is melting. So because it's like a river, those sediments are more salted and little finer and smaller. Now those sediments are called till. T-I-L-L. I don't have it up here, it's just occurred to me, but they are called till. T-I-L-L. Now those sediments, they are salted and they are way smaller because they are coming from the river, melting and gushing out of the glacier as the glacier is melting. Now those sediments, they are very different from moraine that are unsalted and angular. All right, lastly is something that we need to pay attention to when a river is meandering. As the river begins to meander, creating that snake-like movement, that's what you call the head stream. So because the river is curving, making that curvature is going to cause erosion on one side of the meander and then creates deposition on the other side of the meander. All right, the way I typically remember this is I think about the meander as a elbow. So if it's a elbow, there is more erosion taking place on the outside of the elbow, and then there is deposition taking place in the inside of the elbow. So if this was to be my elbow, this would be the outside. So a lot of erosion is taking place because the river is moving at a greater speed towards this side of the meander. So as a result, it cuts this side. All right, it cuts that and then deposits here because the stream will be slower on this other side. So because it's slower on this other side, it allows for more deposition here, and then because it's faster on this other side, it allows for more erosion at this other end. So as a result, you're going to have a gentle slope on this side and a very steep slope on this side due to erosion. So if you were to take a vertical view of the meander, you see that this side where deposition is taking place will be gentle, and then this side where erosion is taking place will be very, very steep. Again, you have to pay attention to where the river is meandering. As it's meandering, the outside is where the erosion is taking place, where the river is going to have the greatest velocity. All right, that is where it's going to cause a lot of erosion and then little deposition on the other end. And as this meander process begins to get worse and worse, an Oxbow Lake is cut off from the meander, creating an Oxbow Lake right there. All right, I think this picture will do more justice to it. Again, you have more erosion taking place here because as the water moves through the meander, it breaks and causes more erosion here and causes deposition here. So as a result, if you were to take a cross profile from point B to B prime, you will see that more erosion is taking place at B and deposition is taking place at B prime. So because deposition is taking place at B prime, the slope will be very gentle there, and then more erosion on this B side, on more steepness will be right there, compared to when it's just A to A. In the middle is more steady and more equal, but around the elbow, all right, you're gonna have more erosion cutting there and then more deposition on this other side. Wow, and I think this is going to be our last slide here. So like I mentioned earlier on, as the meander begins to get worse and worse and worse, at some point this will be entirely cut off. All right, after thousands and thousands of years, this will be entirely cut off, and it is that cut off that is referred to as an Oxbow Lake. All right, and then as we said earlier on the outside of the elbow is more erosion, and then on the other side will be more deposition. So as a result, you're going to have a gentle slope on where the area is being deposited, and then a very steep slope where erosion is taking place. And the last picture here tells you about the creation of an Oxbow Lake. As the meander gets worsened and gets more meandering and gets more snaky, after a while all of this is cut out, creating an Oxbow Lake. Wow, and that is a wrap, ladies and gentlemen. Yo, did it. That's the end. That's the end. That's the end. Okay, I know this video is a little bit longer than the other ones, but we need to do a little bit of practice before you do your own practice in your packet. Question number 1. The diagram below shows the gradual stages 1, 2, 3 in the development of a river delta where a river enters an ocean. Which statement best explains why the river delta is developing at this site? All right, the rate of deposition is less than the rate of erosion. For a delta to be created, there has to be more deposition. So deposition cannot be less. So this is out of the way. The rate of deposition is greater than the rate of erosion. Yeah, it sounds like B to me. The sea level is slowly falling. The sea level is slowly rising. No, C is out of the way. D is out of the way. Question number 2. You have this lovely diagram there. Briefly explain why deposition of sediment usually occurs at where a stream enters a lake. So why is more deposition occurring as at that point where the stream enters into the lake? That's what it's asking you. The reason is simple. It's because that's where the speed of the river slows down, so the river loses energy. So to answer that question, because the speed slows down. The speed slows down. So as a result of the slowdown of the speed, deposition begins to take place there. All right, question number B says, name the type of sediment most likely represented by the letter X right around here. So we said as the river reduces in energy, it drops the heavier guys right around there, and then the middle guys right around there, then the next smaller guys right around there, and then silt. So after silt, what could be smaller than silt? Of course, our answer would be clay, if that is done right. So yeah, clay will be the smallest and the one that will travel the farthest into the ocean because they are very, very small. All right, question number 3. Identify the triangular shape depositional fissure indicated by C. So we see that fissure there, titled C. So it's asking what kind of landform is that. All right, it's fan-shaped, and the river is joining into the ocean, so it's a collection of distributaries. So that is a delta. That is a delta where the river empties itself into the ocean. Question number 4. The position within a meandering system usually occurs on the inside of the curve because, so remember what I told you, when the meandering is taking place, imagine it to be a elbow, so there is more erosion taking place outside, but more deposition taking place in the inside, in the inner side. So it's asking why there is more deposition in there. And the reason for that is because the water velocity decreases. Yeah, the water velocity decreases around that area, allowing for more deposition. Okay, I think that's it. Question number 5 says, what is the name of the fissure indicated by X? So we see that this is kind of a highland. It's very thin, it's very stretched, all right, and then it's trying to separate the continent, Texas, from the ocean, the Gulf of Mexico. So definitely that would be a barrier island that we discussed earlier on. So our answer here would be a barrier island. All right, 2 more minutes. Let's get to question 6 and hopefully 7. Which agent of erosion is primarily responsible for the formation of the barrier islands that we see right here? So we see that barrier island all across that area. So to answer the question is definitely is wave action. It's the action of waves, all right, because it's waves that are dominant in the coastal area where lots of deposition take place. So our answer there is definitely wave action. And I think the same thing would apply to question number 8 here. Which agent of erosion most likely formed these barrier islands? So we see all of those barrier islands right there. So what would be forming that definitely will be wave action. Question number 7 says, which natural agent of erosion is mainly responsible for the formation of barrier island along the southern coast of Long Island in New York? Again, definitely is the ocean waves forming all of that. I think that's a good wrap. We don't have to exhaust the entire 25 minutes. All right. Hope you understand that. Let me know. I will appreciate any feedback on this packet, and then we'll see you when you come back in the building. All right, did an entire unit on the packet. Good job, guys. All right, bye.